All right, we're going to be calculating the rate and time for investments. Okay, here we're asking how long will it take something to happen. So we start with the formula, the future value. I'm going to make this a little bit bigger. Okay, the future value equals the present value times 1 plus r over n to the nt. And we're going to be solving this for t. So the first thing I'm going to do is isolate this argument by dividing each side by PV. So the future value over the present value is equal to 1 plus r over n to the nt. Now the variable we're solving for is in the exponent, so we're going to log both sides. And actually it doesn't matter if you do a natural log or a base 10 log, but because we will be working with e in later equations, I'm going to do a natural log so that you don't have to remember and think about which log to use. Okay? So this will become nt log of 1 plus r over n. Now we're solving for t, so we're going to divide out this and this. So t is going to be equal to the log of future value over present value over n times the log of 1 plus r over n. Now if you just write down this formula and use it directly on the test, that's perfectly fine. You don't need to derive that stuff, but I did want to show you how that stuff is arrived at. Okay, so our t is equal to the natural log of the future value over the present value. So here's our future value, there's our present value. So we have the log of 8,000 over 5,000, and that's going to be divided by, we're compounding annually, so this n is 1. You don't need to write 1 times, but I'm going to write it. Log of 1 plus r over n. Here's our r, 0.1 divided, and you don't have to divide by 1, but I'm just going to do it so you can see what I'm doing there. And we're going to get, now if you don't know how to use your calculator, if you hit the math button up on the top left, is the second, a couple buttons under the second button. If you hit the math button and then hit the left arrow on those circular 4 circles, if you hit the left one and then hit enter, you'll create a stacked fraction. And when you create a stacked fraction, you don't need to put parentheses on the top and bottom of the fraction. So the parentheses are implied. So in other words, you don't have to create that parentheses and this parentheses, which makes your work look a lot cleaner and nicer. So I would recommend hit math and the left arrow, then enter, and then typing in your numbers. You also don't even have to close your parentheses on the top and bottom of the fraction. The calculator will close those for you, so if you want to save even yet another step. But I'm getting out 4.931 or something like that. Now it's to the minimum number of years. So because this time is always going to be expressed in years, all I have to do is round this up. So this is going to be, because it's the minimum number of years, so whole years, so 5 years. Now, something kind of odd. If I use the word minimum here, it doesn't matter if this is a 4.1 or 4.2, you're going to round up to 5, because if you had rounded down, that wouldn't be the minimum number. You'd be shy of this 8,000. So you need to round up always. So you got to look to see if the question's asking for the minimum or the closest. If it says the closest, then you just have to round off the way you've always known how to round off. But if it uses the word minimum, you round up no matter how small this decimal part is. Okay, number 2 is again asking how long. So I'm not going to derive the formula again. I'm just going to use it this time. The time is the log of the future value over the present value, n times the log of 1 plus r over n. Okay. And this time we need to grow to 6,500. So that's our future value. So we're going to have 6,500 over, that's our present value, 4,000. And we're going to compound quarterly. So our n is 4 log 1 plus, our rate is 16%. And again, we're compounding quarterly. Okay, so this is going to become, okay, I got 3.09-ish, something like that, 3.09. Now, it says that it wants the minimum number of quarters. Now, this 3.09 is in years. If I want to convert this to quarters, what I do is at first, I want to figure out what this fractional part of a year is. So I'm going to take away the years. I know my answer is going to be 3 years and then some number of months, right? So I take this away and I get 0.09-ish. There's a bunch of numbers after that. And then I'm going to take that number and multiply by 12 to convert that into months. So I have times 12. Now, again, so I'm going to get 1.13 or something like that. But it asks for the minimum number of quarters, of month. This is going to be, I need to express my answer in quarters, but using months. So I know that's kind of weird, but I'm going to say either 0 months, 4 months, 0 months, 3 months, 6 months, 9 months, or the full year. Okay? So this has to get rounded up to the next quarter, which is 3 months. Now that was kind of confusing, but this to the nearest quarter is going to be 3 years and 3 months, because quarters happen at 3 months, 6 months, 9 months, and 12 months, and this means that I have to round up to the next nearest quarter, which is 3 months, regardless of how small the fractional part is. Okay, again, this is how long, so I'm going to use the formula. T is equal to the log of the future value over present value, n log of 1 plus r over n. Okay, and we're going to double. So our future value is going to be 20,000 because we're doubling our original 10,000. But we know that this division is going to be 2. So you don't have to say 20,000 over 10,000. If you're doubling, you're just going to have a log of 2. If you're tripling, it would be the log of 3. Okay. Over, we're compounding daily. So this is going to be 365 log of 1 plus, our rate is 13%. And again, we're dividing by 365. Okay. So this is going to come out to, remember, I would hit math, left arrow, enter to create a stacked fraction. Okay, I got 5.33-ish. Okay, now this means 5 years and 0.3 years. And we want to the nearest minimum number of months. So I need to figure out what percentage this 0.33 years is, how many months that is. So I'm going to take out my 5, and again, I know it's 5 years, okay? This is 0.33 with a bunch of numbers after it, and I'm going to multiply by 12 to convert this to months. And I get 3.99. So I'm going to round this up. And remember, even if it was 3.1, I'd still round up to 4 because it's asking for the minimum number of months. But this is going to be 5 years and 4 months. So it would take 5 years and 4 months for $10,000 to double at 13% compounded daily. Okay, so here we're being asked, it's asking what rate do we want. So again, I'm going to derive this formula. You only have to do this once. If the future value is equal to the present value times 1 plus r over n to the nt. Now notice the variable we're trying to solve for is inside of this argument. So, well, let's start by getting rid of that PV. I'm going to divide. Oops, let me undo this. I'm going to divide each side by PV. So I get. Now, I want to get rid of this exponent on each side. So I'm going to take each side to the 1 over NT. So in other words, I have future value over present value, 1 over NT. And this is going to be, now I've gotten rid of the that exponent, okay? Now I'll move the 1 over to the left through subtraction. So I have future value over present value, 1 over NT, minus 1 is equal to R over N. And finally, I'm going to multiply each side by N. So I'm going to get R is equal to N times the future value over present value, 1 over NT, minus, and then I'm going to just distribute, and I'll have 1 times N is N. So there's my formula, okay? I'm going to use this later whenever I have to solve for R. So in this case, I have R is equal to, now N is compounded annually, so that's 1. Normally you don't have to write that. It's going to grow to this amount, so that's our future value. We started at this, so that's our present value. 1 over, 1 is N, T is, where am I, 5 years, minus N, which is 1. So let's try this. Okay, I got 0.1184. Now, if you got something different, my guess is that you may have done the minus 1 and left it up here in the exponent. You have to make sure you hit the right arrow to bring it back down so that this minus 1 is no longer in the exponent of this calculation. That's a common mistake. So then I'm going to move the decimal place over twice. You know what, I'm going to put one more digit. There was a 2 after this. Okay. And now I'm going to move the decimal place twice, so this is 11.842%, but it says to round to the nearest hundredth of a percent, and it says nearest, so I'm rounding to the closest, not rounding up. So this is going to be 11.84%, and that's rounded to the nearest hundredth of a percent. Okay, here we're solving for rate again, so I'm going to just use the formula. Rate is equal to N times future value over present value, 1 over NT minus N. All right? And we're compounding daily, so this is 365. Our future value is going to grow to that amount, so 13,500 from that amount. 1 over, and again, this is daily, so 365 for 11 years. Okay, minus N, which is 365. All right, this is going to come out to, okay, I got 0.05344. Okay, and when I move this twice to the right, I'm going to get 5.344%, and it says to round to the nearest hundredth of a percent, so this is 5.34%. Now, if you did not get that value, my guess, it has to do with this right here this time. If you did 1 divided by 365 and then you said times 11, what you did is you brought the 11 into the numerator. So you either have to open a parentheses here and close it there, or you have to make a vertical fraction like I talked about before, or you can simply hit divide again, go 1 divided by 365 divided by 11. And then remember, you got to drop your cursor down to do this. Okay? Make sure you've practiced that before you get to the test. Okay, and again, it's asking you to solve for rate. So I'm going to just use the formula that we already know. Rate is equal to N times the future value over the present value, 1 over NT minus N. Okay, so we are compounding monthly, so this is 12. the amount of interest is 5250. That's not what we started with. We started with 12,700. But we're not ending at 5250. We're getting 5250 more than that. If you don't feel like figuring it out, just do the addition up here. Or you could just add it and then put the added value in there. But this is going to be 1 over, this is 12 compounding monthly for 14 years. Minus 12 here. Okay, so make sure you can get this. Oops, I put 127, 12,000, I don't know what I did in the numerator, but that's a mistake, obviously. Hopefully you caught that. That 5 shouldn't be there. This should be 12,700. Okay. Okay, I got 0.024739 or something like that. Okay? So this is going to be, moving the decimal place twice, is going to be 2.473. But rounding off to the nearest hundredth, it's going to be, let's see, 2.47%. Notice it said the nearest hundredth, not the minimum percent needed, but the nearest. Okay. Okay, so we're looking for the rate, and this time we're compounding continuously. So the future value is equal to the present value times e to the RT. All right? I'm going to divide each side by present value. So future value over present value is equal to e to the RT. Now we're after rate, which is in the exponent of e, so we're going to have to natural log everything. So I'm going to natural log the left, and I'll natural log the right. And when we natural log e, we just get RT. So finally, if we're solving for rate, time is going to be equal to, we're solving for rate. I'll just do this. Rate, I'm going to make this a little nicer. Rate is equal to the log of future value over present value over, I'll put those parentheses, over t. Okay? So our rate is equal to, we want to earn 12,500 in interest. Now that's not our future value. Our present value is that amount there though, 22,800. Our future value is what we started with plus the interest. And this, oops, I didn't leave myself very much room. Let me erase some stuff here. It's the log of that over time, which is 5. So this is our rate. Okay? So this is going to come out to, okay, I got 0.08742. And then if I move my decimal twice, this is going to be 8.742%. But if you round this to the nearest hundredth, it'd be 8.74%. All right. Okay. We're after how long, that's time. So the original formula is future value is equal to present value times 1 plus r over n to the nt, and we're after this t up here. So let's get rid of this present value by dividing each side out. Now I want to get that exponent down, so I'm going to log each side. You can natural log or you can base 10 log. I'm going to natural log, so I don't have to remember which one to do for each type of problem. I'll always be using a natural log. It really doesn't matter what you use here. Okay, and then I'm going to be solving for t, so I got to divide this stuff out. So t is going to be equal to the log of the future value divided by present value over n log 1 plus r over n. Okay? And let's put in some values. Okay, so our t is equal to the log of our future value over our present value. Well, there's our future value, 22,750, over our present value, which is that, over, we're compounding quarterly, so our n is 4, and we're investing at 13%. Again, quarterly. Okay, so this is going to come out to, okay, I got 7.248 or whatever. So this tells me that it's 7 years. So I know my answer is 7 years. Now to figure out how many months, I'm going to subtract out my 7 to leave me with this 0.248 with all that stuff after it and multiply by 12. And I get 2.98 months. And it says the minimum, and it's a quarter. So quarters happen at 3 months, 6 months. So I have to round up. No matter how small this number is, I have to round up till I hit either a 3, 6, 9, or 12. I hit a 3 first, so this is 3 months. I have to round up until I hit 3, 6, 9, or 12 because it's asking for the minimum quarter, not month. So you would never have 4 months or 5 months because those aren't quarters. All right. Okay, again, this is how long, so we're after time. So I'm going to use the same formula as I did in the last step. Okay, there it is. And now this is $25,500 in interest. That's not our future value. So when we do this, we're going to have the log of our present value is this. That's what we're starting with. Okay. But we're earning this in interest, so we're going to end up with $25,500 plus our original amount. And this is going to be over, we're compounding daily, so this is 365 at 14%. And I'm going to get, I'll get 2.3645 or something like that, some numbers after it. So that's 2 years. It wants to know the minimum day in years and days. So this 2 years, I'll put 2 years, and then I'm subtract out the 2. So this is a portion of a year, 3645 or whatever. I'm going to multiply this by 365 to get the number of days. And I got 133.03. But it's the minimum, not the closest day. So I have to round this up. So this is going to be 134 days. Okay, here we're compounding continuously, and it's asking how long. So future value is equal to the present value times e to the RT. And we're after time. So I'll divide each side by present value. Now to get that variable out of the exponent, I'm going to natural log each side. And then we're after time, so I'll divide each side by r. Okay, so time is equal to the log of, it's going to $185,000 from $82,000 and at an interest rate of 12%. It's that simple. This is going to come out to, okay, so I got 6.78-ish. Okay, Now, it wants the minimum day in years and days. So let's subtract out the 6, and I'm going to immediately put 6 years in my answer. So it's 0.78 years now. I'll multiply this by 365, and I'll get 284.8. But it wants the minimum, so I have to round up. No matter how low that decimal part is, I'm going to round up to 285 days. So this would take a minimum of 6 years and 285 days. Okay, so we're after the rate. We're compounding continuously. We've already solved for this, so I'm going to do it again. We did this in a few problems ago. Okay, so this is the formula we're going to use, and we are going to, our future value is going to double. So I don't care what it begins and what it ends at. After I divide it out, we're going to have a 2. If it tripled, we'd have a 3. This is 8 years. So that's all you do. And I'm going to get 0.08664 whatever, which is 8.664% rounded to the nearest now. So I'm not going to round up. I'm going to round off. So that 4 makes it go to stay at a 6. So 8.66%. So pay attention to the little words there. That's the nearest, not the minimum number. All right, and that's it.